So today we are looking at the data frame attributes like index, column access, data types, size, shape, MTT, and so first of all, we are creating a data frame that is through a nested list. I have a list in which there are 6 other lists containing values from 1 to 18, 3 values in each. Now when I print the df, I could see that there are 0, 1, 2, 3, 4, 5 row index. That means 6 rows are created, and 0, 1, 2, that is the column index. That means 3 columns are created. Now in order to name or label these index and column, that is row and column index, we'll use df.index equals to, I am giving a list of the values or labels I want to put it, and similarly using df.columns equals to, I'm putting up a list of the column labels I want to. Just be careful that the number of rows or columns there are already, only those number of labels should be given, otherwise it would provide an error, right? Now we have already seen 3 arguments could be given in a defining a data frame, that is index, columns, and data. Now even if we don't write data equals to, it is fine. We can put index equals to, columns equals to, and if we have skipped that, we can use df.index equals to df.columns equals to, and it will do the same. Now when I print df, I can see that 6 rows, row 1, 2, 3, 4, 5, 6, and 3 column 1, 2, 3 are created. Now when I write df.index and I print it, what I could see is the output index. Then there is a tuple where first of all it give me the labels of the rows, comma the d type, which is the object, as these are string labels, right? Now similarly when I do df.columns, the output is that index, then a tuple is made, inside it is the list of the column labels I put up, comma the d type equals to object, because the row label, column labels are strings, right? Moving forward to df.access. Now first of all you can see that here the df is, which we have already made. Now when I write df.access, AXIS, it gives me an error. So this should be very careful with that. Here we'll use df.access where AXES should be used. Now when we do say access, that means row plus column label. That means X and Y both X's. So here it create a list in which it write index and then a tuple of the row labels with d type, comma index, then again a tuple of the column label, comma d type, and the list ends there, right? Now moving forward to, we'll see transpose, endim, d types, and empty. Now the transpose function, first of all, it converts the rows into columns and columns into the rows. For accessing it, we write df dot capital T. If we'll write a small t, it will give us an error, and writing transpose in small letters will not suffice. It could be given output, but it will not be a viable output. Now when I write df dot capital T, the output we can see here that the first row in the df was 1, 2, 3. Now it has become our first column. Similarly, the first column, which was 1, 4, 7, 10, 13, 16, has now become our first row. Okay, so the rows are converted into the column and columns are converted into the row. This is the work of transpose. Similarly, when I write df.endim, that means number of dimensions, because it is a row and column structure. That means it is 2-dimensional. 2 is thus the output. Now when I write df.empty, that means it check if the df is empty. If it does not have any value or it has not a value in all its position, then it will give us a true. However, all the values here are fulfilled, thus it tells us false as the output. Now when I write df.type, it gives me an error, because here there are different columns for which different data types could be used, as a data frame is a heterogeneous data, combination of heterogeneous data. However, we have seen in the series that series.dtype, series.dtypes both give us the correct output. However, in the case of the data frame, we'll use df.dtypes. Okay, the S is here complementary. Now we see that when we print it, it tells us call 1 equals to int64. Similarly 2, 3, it tells us that all these columns contain the data which is of integer type, and at the end the D type is object. Why is it so? Because the data frame is heterogeneous data, so its different columns could contain different kind of data. Thus always the complete D type is shown as object. Moving forward to df.shape and df.size. First of all, we'll see df.shape. It tells us in a tuple format. What is a tuple? That is some data inside parentheses or brackets. Thus here the df.shape tells us in brackets number of rows comma number of columns that are there in the data frame. Here we can see in the data frame that 6 rows are there and 3 columns are there. Thus when we print df.shape, the output is in the tuple 6 comma 3, that means 6 rows 3 columns. Now when we print df.size, it tells us number of rows multiply number of columns. That means it tells us how many elements are there in total. Number of rows multiply column. Now we have seen that there were 6 rows and 3 columns. Thus the output here is 6 multiplied 3, that is 18. Please follow us on Instagram as well as for notes and PPTs and the video notification. Please follow us on the Telegram. The link is in the description.